People today need to use presentation software in business, education, and artistic settings. In this work, we seek to make what we call digital artboards in this presentation software accessible to blind and low vision users. Software like Microsoft PowerPoint, Google Slides, Apple Keynote, and Adobe Illustrator use artboards to hold objects like text, shapes, images, and diagrams. But for blind and low vision or BLV people, using such software to read and write artboards is a big accessibility challenge. Prior work shows that BLV users usually experience high cognitive load of remembering complex 2D content, difficulty of determining objects' relationships, and uncertainty of whether an operation has been successful. In general, we seek to address the fundamental challenge that conventional screen readers were developed to handle text in a linear, one-dimensional information stream, while a digital artboard is inherently a two-dimensional space with rich context. For example, an artboard showing the left side that has some shapes piled together will be reported by NVDA and Windows Narrator like this.
Slide 1, slide view. Rectangle obscured. Isosceles triangle. Rectangle. Rectangle. Oval.
Slide 1, slide. Rectangle 1, shape. Isosceles triangle 2, shape. Rectangle 3, shape. Rectangle 4, shape. Oval 5, shape.
To address these challenges, we present A11yBoard, a multi-device, multimodal interactive system that makes digital artboards accessible to interpret and author. A11yBoard consists of rich features like touch and gesture to explore the artboard in a risk-free way, audio and speech commands to access detailed properties, and intelligent keyboard search to handle other properties that are not easily manipulable using touch, gesture, and voice. A11yBoard builds on top of a web-based artboard tool, usually appearing on the desktop or laptop and mirrored onto a touch display. Now we demonstrate how A11yBoard works through a few example scenarios. We first show how A11yBoard is used to interpret an artboard with multiple objects inside.
Black text box. Dark gray rectangle. Khaki text box. Dark gray rectangle. At 61, 127, with bounding box of 637 by 186. Needed ed. Indian red rectangle. At 820. Micon.
Position.
From canvas left, 80% of canvas width. From canvas top, 57% of canvas height. From canvas right, 17% of canvas width. From canvas bottom, 30% of canvas height.
Left exact.
From canvas left, 820 pixels.
Color.
Indian red.
Color exact.
Red, 192, green, 80, blue, 77. Mic off. Dark gray rectangle. Dark gray rectangle at 61, 127, with back. Mic on.
Closest to.
The first nearby object is a black text box to the north-northeast. The second nearby object is a yellow-green triangle to the east-southeast. Mic off. Nearest object at 16 degrees is a black text box at 59, 30, with bounding box of 640 by 81. Nearest object at 54 degrees is a yellow-green triangle at 781, 284, with bounding box of 154 by 141.
We then show how A11yBoard is used to create and edit objects on an empty artboard.
Black text box. Mic on.
Create rectangle.
A rectangle has been created. Mic off. Mic on.
Resize bottom right.
A yellow-green rectangle will be resized. Mic off. Mic on.
Here.
A yellow-green rectangle has been resized to 326, 239, with bounding box of 5. Mic off. Mic on.
Move.
A yellow-green rectangle will be moved. Mic off. Black text box. Black text box at 59, 38, with bounding box of 633. Mic on.
Align left to left.
A yellow-green rectangle has been moved to 59, 239.
Align top to bottom.
A yellow-green rectangle has been moved to 59, 119. Mic off. Ready. EDI. Text edit. Accessible artboard. Backspace. Shift T E. A black text has been set to title. Command cleared. F O. Font family. Georgia. Backspace. N A I. Arial. A black text has set font to Arial.
A11yBoard supports a variety of touch and gesture, speech, and keyboard commands which can be found in the paper. From our usability test with 8 BLV participants, we show that participants completed Artboard interpreting and authoring tasks far better than what has been reported without A11yBoard. Post-study interview also indicate that A11yBoard provides intuitive spatial reasoning, multimodal access to objects' properties and relationships, and eyes-free creating and editing objects experience. Finally, we show a few participants' responses from the user study.
I really like it because using your fingers. I mean, you know, I'm such a tactile user because I read Braille and all that. So it just makes really good sense to me. And then I have a good spatial sense, which helps a lot. So yeah, I like it a lot.
I would have been so happy during the school year. I would have made slides for days. This is so promising.
Thank you for watching.